It's silly, but just so you can remember that these are particularly special notes, let's call them special notes. Okay. If I am open to name suggestions, if you have a better idea of what we can name them, I'm all for it. Okay, but just right now I'm gonna call them special notes. That way you know they're special. Bless you. Okay, these deal with how to graph okay. Polynomial functions when they're factored form. Big old title. Okay, but so when you're looking through your notes, you know what they are. Okay. And so we're going to deal with some specific words like zeros, multiplicity, and degree. Okay. So a lot of these are new. Okay. And so just bear with me at first. I'm just going to first tell you what they are, okay? And then I'll tell you what they do. So let's start here with this. Let me just write this down. Let's do f of x equal x plus 2, x minus 1. Okay, so what's the goal? Okay, the goal is this. I give you an equation like this, and you sketch it, and your sketch is pretty accurate. Okay, right now you don't know how to do that. Look at the equations on that paper; they're even more complicated than this, right? Like how would you sketch that? If I said, "Hey guys, go ahead and sketch that," the only thing we know how to do right now is make a table, and these are pretty nasty, so it'd be kind of tedious to do a table for these, right? Because you have a third power, a fourth power. And believe it or not, by the time we're done with this today, you'll be able to knock this out. You'll be able to sketch it within 30 seconds. Okay, so that's what I'm going to teach you. First off, let's start with this. Multiplicity refers, those are just the powers of those things. Okay, if you don't see a power, it's a number 1. It's a power of 1. So that's multiplicity. So right now, if I was showing you a car, I'm just telling you, look, this is the tire, this is the muffler, this is the wheel. I'm just telling you the parts. And then in a little bit, I'll tell you what they do. Okay, so that's multiplicity. Let's go up a little bit and let's talk about degree. Okay, so number 1, what's a degree? More specifically, the degree of the function. Okay. Why do we need a degree? Basically, it's going to give us a preview of the graph. Okay, that's what we use the degree for. If you tell me the degree, I can tell you what it's going to look like. Okay. And so the degree for this problem up here would simply be, I would just take the powers, so power of 1, and add them, power of 3, power of 4. You just add all the powers. So if I add those powers, that's an 8. Okay. So I would say the degree of this function is 8. It's an 8th degree polynomial function. Okay. Polynomial because it has many parts. Okay. Let's keep going. So what we're going to do now is we're going to compare even degree. I just showed you how to find the degree. We just add the powers. And I'm going to tell you what it looks like, why it matters. What does it do? Okay, versus odd degree. Okay, so what's the difference between an even degree and an odd degree? Thank you. Okay. Here we go. So, and just to be really clear, so there's no ambiguity whatsoever, whatsoever. Even degrees would be numbers like 2, 4, 6, 8, so on, so on, so on. I know you guys know that, but just to be clear, 1, 3, 5, 7, so on, so on, so on. Okay. Even degrees, odd degrees. Okay. So here we go, guys. You actually already kind of know this. You just maybe haven't connected the dots. For example, if I do a x squared, that degree is even. What does it look like? Right, a parabola, right? I think we did this the other day, so I don't want to do it a whole lot, but let me show you one time just in case you weren't here that day. If I go to Desmos here, if I put a square, it makes a parabola. What I want you to notice is the arms. Both of the arms are going up, right? If I do another number that's even, like 4, a quartic, the arms are still up. Right? If I do even a bigger number like 44, it doesn't matter, the arms are still up. So no matter what even power I use, I could use a huge 4444, it's still the arms are pointing up. Okay, so, and I'm going to go ahead and show you the odd one, just so I don't have to flip pages again, right? The odd, so a power of 3, what I want you to notice here, left arm down, right arm up. Okay. Same for if I do 33 or 333. Left arm down, right arm up. Okay, so we use this information here. So we know that if it's an even, it's going to be like a parabola. Okay, so it's going to look. Now these are polynomials, so it's not just going to be a U or have some squiggles in the middle. But the point is the arms. Both of the arms are still pointing up. Okay, that's the point. The odd one, that's like the cubic function. Cubic, sorry, not y, but x is like the cubic function. It comes from the bottom and leaves through the top like that. Right? It's a little S shape. So this one will look like that, but it'll have maybe some extra squigglies in the middle. Okay, but again, the point is not the squigglies right now. The point is down, up on this side. Okay. Everybody good so far? We're on the same page? Any questions so far? So we're just building, okay? Building. Okay, let's keep going. Let's separate this. So these are your super notes, so I just wanted to make sense to you. So separate that real quick and let's write what happens if you put a negative in the front. So on the coefficient, if the coefficient is negative, so an example of this would be something like this. F of x equal a negative x squared, x minus 1 cubed, x minus 3 to the 5th power, something like that. Okay. What I'm referring to here is this. Okay. That negative in the front. And you guys know this already. You know it with the parabola, especially. So again, we're talking about even degrees and odd degrees. Okay. What happens, guys? You guys know this. A parabola. You put a negative in the front. What happens to that parabola? Flips it. Reflects it. Right. So a normal even function would be a w. This one, if you flip a w over, it'd be like a m. If you flip the w over. Okay. This one, I have to graph the original one so that I can flip it. Okay, so this left arm, instead of going down, will go up. Squiggly in the middle. Instead of going up on the right, it'll come down on the right. So I flip it. Okay, okay, we're good? Easy peasy? Okay, here we go. Let's keep adding then. Part 2. Let's get to the examples. Okay, so here's the first one we're going to graph. Okay, we're going to put all the pieces together on this one. So let's do f of x equal x, x minus 1, x plus 3, x minus 5. Oh, the powers. Let's do a 2, 3, 4. So the first thing is I want to know what this is going to look like kinda, right? So not kinda, pretty close, degree. So I need to know the degree. Okay, so remember, if it doesn't have a power, what power is it? Make sure you put that there. Okay, it's not a zero. Some students want to treat it like a zero, but it's not. It's a 1. So my degree for this one would be 1 plus 2 plus 3 plus 4. Okay, you're adding, these are your super notes, so I want to make sure they're clear. You're adding all the powers. So what do we get when we add that? 10. Okay, now here's why it matters. 10 is even. Even power looks like a W. Yeah. So I know what it's going to look like already. It's going to be like a W because it's an even degree. Okay. Now here's a new part. Okay. You've done this in Algebra 2, but we haven't done it together. So this is the first time we've done it. We need to find the zeros. I haven't told you yet, but who here remembers what's another word for zeros? X-intercepts. Okay, so put here X-intercepts. That just means zeros just means X-intercepts. We're going to find all the X-intercepts. So how do we find all the X-intercepts? Here's the instructions on how to do that. You set your factors equal to 0 and solve for X. Solve. Okay. So here's what I mean. So what are the factors? In case you don't know, these are the factors. Factors. That's a factor, that's a factor, that's a factor, that's a factor. That's a factor, factor. And the other one over there. Those are the factors. Okay, it just means what you're multiplying. This is multiplying times this is multiplying times this. So those are the factors. I'm going to take each one of those, there's 4 of them, and set them equal to 0. So here we go. My first one is X equals 0. My next factor is X minus 1, set it equal to 0. X plus 3, set it equal to 0. X minus 5, set it equal to 0. You set each one equal to 0. And then we solve them. Okay? Solve means get X by itself. X is by itself on that one. There's nothing to solve on that one. Okay? On this one, I would have to add the 1 to both sides. And so you get X equals 1. There's your next X-intercept. And then you get how it works. So what would this one be? -3, and the last one? 5. And that took all but 5 seconds to do. Okay, and now you have all 4 X-intercepts. Okay, so let's see what we have so far. Let's put it on a graph. Let's make a grid. Okay. We have X-intercept at 1, there's 1, 1, 2, 3, 4, 5. We have one at 5. We have one at -3 and one at 0. So I'm going to put these points on here. I have an X-intercept here, one at 0, one at 1, one at -5. Okay, what we said earlier, it's going to look like a W, right? So it's going to come in like this and go like that. Okay, so I'm going to come in from the top, and then I'm going to hit that X-intercept. Okay, guys, but here's the catch. Okay, watch this carefully. I don't know right now. Okay, we're missing one piece. There's a piece you're missing. In this part, don't write this down. Okay, what I'm about to do. Should I go like this, or should I go like that? We don't know that yet. Okay, so we're missing that piece. So that comes from something that's called multiplicity. Okay, so let's go back up here and let's do multiplicity. This is the last piece. Once you get multiplicity, we have everything done. Multiplicity. Okay. So remember, those are these, the powers of these. So this is a multiplicity of 1, because it's a 1 power. Multiplicity of 2, multiplicity of 3, multiplicity of 4. Okay, I'm going to write it down here because I want it close to my graph. So multiplicity of 1, multiplicity of 2, multiplicity of 3, multiplicity of 4. Everybody see where that multiplicity number is coming from? Is this the power of each factor? Okay. All right. Here we go, okay. 1 is odd. 2 is even. 3 is odd. 4 is even. Even, odd are going to tell us what to do, okay? If it's even, it's going to bounce. The new thing, okay, this is the last piece of the puzzle. So even, bounce. If it's odd, opposite of bouncing, like instead of bouncing off of something, is you can go through that something. Okay, so we'll call it cut. Or you could say pass through it, cut through it. I don't know what other word. So if it's odd, it goes through it. If it's even, it bounces. The real math words here, which matters, is for bounce, that's really called a tangent. And cut is really intersect. But right now, since we're just keeping it easy, we'll just say bounce and pass through. Okay, guys, so here's the last part. Check this out. I come in, watch this, okay? This is really important that you get this last part. I come in, I hit -3. At -3, I cut, I pass through. So I'm gonna pass through it, go to the next x-intercept. My next x-intercept is at 0. I cut through. So I'm going to pass through 0. Go to the next x-intercept. I hit 1. At 1, I bounce. So instead of passing through, I bounce up. And then I go to 5. And at 5, I bounce. So instead of passing through 5, I bounce up. And there it is. There's the first sketch, okay, of a polynomial function. That one's a little hard to swallow the first time because it's the first time you're seeing a lot of that. It's going to get easier and easier and easier, okay? My last classes, by the last example, 90% of them were doing it like this. So, any question, though, that you have right now? Okay, watch this example 2 already will be much smoother. Okay, let's do example 2. On this one, keep on your super notes. After this, we'll go to your other notes. So example 2. Let's do f of x equal -x squared, x minus 4 cubed, x plus 1 squared, x minus 3 to 5th. I don't know, let's look at this. This is nasty. It's a nasty, long, big old equation. How are we going to graph that? It's pretty neat that here in a few minutes, in 15 minutes, you'll be able to graph this with ease. Okay, so let me guide you through it one more time. The first thing is you want to know the degrees. Okay, if you know the degrees, you know what it kind of looks like. Okay, so let me see, because this is kind of far from the screen. Okay, so what degree would this be? 12, right? Okay, so 12. 12 is even, right? 12 is the even, so it's going to be like a W. Normally, why did I say normally it'll be like a W? Because we have a negative in the front. I guess we have to be careful with that negative in the front. That negative in the front is going to flip the W. So instead of a W, I'm going to have like a letter M, okay? Because it flips it. Now look how easy the zeros are. This time I'm going to give them to you faster, watch. This one is, you just move the 4 over, so it's just 4. That one you just move the 1 over, so -1. That one you just move the 3 over, so 3. In 5 seconds, I have my 3 x-intercepts. Now, I also have this one, negative x squared, so I set that equal to 0 and solve, okay? What number can I square, multiply by a negative, and still get 0? 0, okay? Check this out. Let's actually solve this. To get rid of the negative, you can divide both sides by a negative. 0 divided by negative 1 is 0. To get rid of a square, you square root both sides. Square root of 0 is 0, right? So, by the way, notice that if there's not like a plus or minus or something like that, it's just 0, okay? So there's our 4 x-intercepts. Okay, let's start sketching this. So I have one at 4, 1, 2, 3, 4. So I'm gonna have one here, I'm gonna have one at 3, and I'm gonna have one at negative 1, and I'm gonna have one at 0. Okay. So negative 1, 0, 3, 4. There's your x-intercepts. Now it has to look like the m, so I have to come in from the bottom. I'm missing my multiplicities, so I don't know if I should bounce or pass through. That's where we need the multiplicities. So multiplicity for this one, that's too big. Okay, would be 3. Multiplicity for that one would be 2. Multiplicity for that one would be 5. Multiplicity for this one would be 2. Okay. Remember what these mean? I mean, they're brand new, but odd, cut, bounce, cut, bounce. If it's even, it bounces. If it's odd, it cuts. So I can finish this graph now. If I go to negative 1, check this out. I bounce, so it bounces off. And then I go to the next x-intercept. At 0, I bounce. So I'm going to hit 0 and bounce to the next x-intercept. At 3, I cut. So I pass through 3. And I go to the next one. I go to 4. At 4, I cut through. So I cut through. And there it is. There's your letter M. Like we had previewed, we knew it should look like that. Okay. So your information should match this. Okay. If it doesn't, that means we messed up. But it should match. Questions right now, guys? Okay. Put that one up in a safe spot that has all the info, and then get out the other paper. If you didn't get the other paper, it's by the basket in the back by the calculators.